Hello and welcome to a tutorial on how to use my Fresnel lens calculation code. So we can see here that a Fresnel lens has often been used in a lighthouse to take a source of light and to spread that light in a direction as far as possible. Now it does this by taking all the light which comes out at various angles and causing it to so this would make the light travel much further. Now we could actually do the opposite, which is if we had a source of light which traveled perpendicular to the Fresnel lens, it would follow that the light would be reflected inwards to the source and concentrated. So what we want to do is something very similar. We want to take the source, move it to this other side, and we want to have the Fresnel lens be perpendicular to the sun and therefore provide some sort of concentrating dish. Now the advantage of a Fresnel lens over, say, a parabolic concentrator is that a Fresnel lens would be in some ways simply easier to construct. You could simply take a number of smaller mirrors and line it up in a Fresnel array and get a concentrator. Okay, so now let's take a look at the output. When this code is run, we get an output that tells us the first mirror is actually flat and goes from -6 inches to +6 inches, centered around the middle. The second mirror could be placed at 6 inches and elevated at an angle of 0.95 degrees. In other words, if we took the end of the mirror and we elevated it 2/10 of an inch, we would achieve that angle. The second or third mirror would be placed at 18 inches radius from the center, elevated at 1.91 degrees, which is 0.4 inches high at the end of it. So now let's take a look at what this looks like. We can see that light, represented by gray lines, is shining at a perpendicular angle to the dish. The blue lines represent various mirrors and the angles that they form with the x-axis. Finally, the black lines represent the light as it is reflected off of the Fresnel lens and concentrated right in the middle around a focus point. So with this design we can see potentially from different angles as well what the light, slightly different angle, and rerun. We can see that the light is coming in from a different direction, and as it reflects off the Fresnel lens, it is concentrated. This is 360 inches out. It is slightly scattered over the focus point, but still retains a nice focal concentration. So you can feel free to play with this code, and you could even take it through a range of motion and get an idea of what the concentration point looks like at various angles. So, thank you for watching, and I hope you enjoy using this code and constructing your own Fresnel lens reflectors.